Welcome back to Electronics, Simple Circuits and Measurements Fundamentals. In the previous module, we explored the quantities behind Ohm's law, the essential equation for relating voltage to current and resistance. In this module, we will dive into a hands-on activity where we will use components that we've discussed so far to create a simple circuit. Let's state the goal of our experiment clearly. I want to produce and measure a constant 4.5 volt signal, measured on our multimeter. From our kit, we will use resistors, a breadboard, a 9 volt battery, and our multimeter. Before we pause the video to allow time to explore, let's think clearly through the problem. We are given a 9 volt battery, which we know should produce a constant voltage of about 9 volts at all times. How can we use our resistors to reduce that voltage down from 9 volts? And how do we integrate our multimeter such that it reads 4.5 volts? Give yourself a good 3 to 5 minutes to explore this. I'll see you soon. Alright, let's work the problem. First, allow me to pull up a representation of our circuit using the circuit simulation tool called Tinkercad. You'll notice that I've picked components that look slightly different than those that we've talked about. I do this on purpose so that we can be flexible in dealing with variations of components that we will certainly be confronted with in the real world. For instance, you'll notice that this breadboard is rotated by 90 degrees, such that the rows are aligned vertically. This isn't so bad, but you'll also notice that this breadboard has no rails. If your breadboard has rails, let's simply ignore them for now. So, if we attach our 9 volt battery to two separate rows of our breadboard, what have we effectively done? Well, using our multimeter to probe those two rows shows us that we haven't really done anything interesting. The row connected to the positive terminal of the battery is at 9 volts relative to the row connected to the negative terminal of the battery. Here's an example of where I want you to sit back and watch as we explore a common pitfall. What happens if we connect a wire from the positive 9 volt row to the negative or 0 volt row? It's a short circuit. Not only does your multimeter not know whether to measure 0 volts or 9 volts or something else, but an unregulated amount of current is now flowing through this wire from your battery. If you do this for too long, the wire will heat up to the point where it might burn your fingers, and the battery may explode as the acid in its casing starts to boil. Not good. So, back to safety. How do we get this voltage level down to 4.5 volts? One might consider using a resistor, connecting one of its ends to the positive 9 volt row and the other end to the negative or 0 volt row. Great thinking. Now, if we use our multimeter to probe either end of the resistor, what do you expect to find? Again, nothing interesting. Taking a step back, we can see that although there is a resistor in the circuit, our probes are still directly connected to the positive and negative terminals of the battery, through a wire. Unfortunately, there are no other places for us to probe, so what are we missing? What can we add to our circuit such that it creates a point where the voltage is half of where it started at? Take a quick pause and think about it. How about another resistor? If we connect two resistors end to end, connecting one end of the first resistor to the positive 9 volt row and the opposite end of the second resistor to the negative or 0 volt row, well, if we place our probes on the far ends of this resistor string, we shouldn't be surprised to find that we measure 9 volts again. We are still effectively directly connected to the positive and negative terminals of the battery. However, now we have a new place to probe. If we place one probe on one end of our resistor string and the second probe in between the two resistors, we find 4.5 volts. What we've created is a very common and incredibly useful circuit called a voltage divider. Voltage dividers are used to step down voltage in circuits based on a combination of resistors. You'll notice that, since we used two resistors of the same size, that is, they have the same color bands, the amount we restricted the flow of current on the positive end of the circuit is the same as the amount we restricted the flow of current on the negative end. Therefore, the point in between produces a voltage directly between 0 and 9 volts, or 4.5 volts. If we were to use resistors of a different size, what would you expect to see? What if the resistors are still the same as one another, but at a higher resistance? What if they are different resistances from one another? I'd encourage you to pause the video and explore. When you're done playing, try Google searching the term voltage divider equation and discover for yourself the equation that describes the voltage divider. So ends our first hands-on circuit activity. In the next module, we'll introduce more circuit components and explore new modes on our multimeter that allow us to measure new circuit characteristics.